talking about potential energy and kinetic energy. Kinetic energy is the energy in motion, and potential energy is energy that is stored. So when you raise something up, there's potential energy, and when you are moving, that is kinetic energy. Okay, if you open up to the back of your yellow packet and you go to the powerful workout lab, we're going to be looking at kinetic and potential energy. Now follow along with me. It says, does the amount of work that you do depend on how fast you do it? No, but the amount and time which it takes to do the work affects the power. The rate of the work done. In this lab, you'll calculate your work and power for climbing a flight of stairs at different speeds. Then you'll compare your power with that of an ordinary household object, a 1,000-watt light bulb. Our objectives for this lab is to be able to calculate work and power by climbing a flight of stairs and compare your work and power to that of a 1,000-watt light bulb. Before you start step number 1, you need to ask and answer this question. Question number 1, how does your power in climbing a flight of stairs compare with the power of a 1,000-watt light bulb? Question number 2, your hypothesis. Write a hypothesis in a complete sentence that answers the question from step number 1 and explain your reasoning. For example, I would probably write, I think that I will create more power than a 100-watt light bulb by climbing the stairs because I have more power in my legs, or something to that extent. For this lab, you will need a tape measure, a stopwatch, and a flight of stairs. The first step is to measure the height of your stairs. Now, in the packet, it says to measure in meters or centimeters, but because we're using a tape measure, we're going to use inches. Do you see that this one step is 6 inches? The next step is to count how many steps there are. All right? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You guys remember that each step was 6 inches, and there were 16 steps. Going to write that in on this test the hypothesis. There's 6 inches, 16 steps, so the height of the stairs is 8 feet. The next step is to find a partner to help you, time you to going running up the stairs and walking up the stairs.
Ready, set, go.
Stop.
It took 9 seconds.
Okay, go.
2, 1, go. 2 seconds.
Hi guys, let's finish our lab by calculating what we need to calculate going through our table here. Now, if you can remember, we changed this to inches. We changed this to feet. Now, the height of my steps were 6 inches. Yes, I know they look like 8 inches, but we're going to go with an easy number of 6 inches. And the number of steps was 16. And the total height of the stairs was 8 feet. And you write that in your packet. My time for my slow walk was 9.44 seconds. And the time for my quick walk was 2.09. Once you have all this data put into your packet, let's scroll down now and we'll take care of some calculations here. So here's where you're going to have to be very careful and take your time and make some calculations. Make sure you read the directions. So we're using calculations table to analyze your results. Now your weight in newtons, if we go down to number 2, it says determine your weight in newtons and record it in your calculation table. Your weight in newtons is your weight in pounds multiplied by 4.45 newtons per pound. So I weigh 245 pounds. I'm going to times that by 4.45 newtons, and I get 1,090.25 newtons. So this is going to go into this spot right here. So it's going to be kind of hard for me to write this in there, but 1,090.25. Now, yours is going to be different because obviously your weight is not 245 pounds. So you're going to put your weight in here multiplied by 4.45. Now the next part is to calculate and record your work done in climbing the stairs by using the following equation. Work equals force times the distance. So I have to take my 1,090.25 times how tall the steps were. So this part right down here, I'm going to draw a little arrow down here to 3. I'm going to go 1,090.25 times the height of my stairs. So if your stairs are 10 feet, you're going to write 10 feet here, but my stairs were 8 feet. So I'm going to put 8 feet here. And I get 8,722 joules. So that is my work. That number right here, this is going to go into this box here. This 8,722. Okay, now the last piece is to figure out the number of watts. So to calculate and record your output. So power equals work divided by your time. So our work is this right here, this 8,722. We're going to divide that by our time. So if you think back to my running and walking up the stairs, I take my 8,722 and divide that by my slow speed, which would be 9.44 seconds. And I get an answer of 924 watts. So that is going to go into this box right here. 924 watts. Now, how do you think I'm going to calculate for my quick speed? I'm going to do the same thing I did here, 8,722 divided by the time that was faster. So 8,722 divided by my 2.09 seconds gives me a total of, I'm going to round this to the nearest whole, 4,173 watts. This is going to go into this box right here. Okay, 4,173 watts. Hopefully you all got that. Remember, you can go back and pause it, go back and check if you don't really understand what's going on. Once you've calculated these things, I want you to go in here and answer these questions. Okay, evaluating methods, drawing conclusions, applying conclusions, and communicating your data. Once you've done all that, then you are done with your lesson for today. Thanks, guys. Hope you have a good day. Bye.